Welcome back, and thank you for joining me in part 4 of the Intro to Pro C++. In the previous lesson, we looked at creating new C++ console applications, writing out to console, and started using variables. This lesson builds on concepts we covered in part 3, so if you haven't seen that video yet, you can click on the card here or on the link in the description. In this video, we're going to continue with these parts and add capturing user input with standard cin and control logic using the if statement. So, diving straight back in, we're going to look at capturing user input next. But let's start by defining the problem we want to solve. The problem we want to solve is to ask the user to enter some text and display what they've entered. The stages required to do this are instantiate a variable to store the user input, display a message to the user to enter some text. Then we want to capture the user input and pass the value to our user input variable. Finally, we want to display this value to the screen. In the previous lesson, we created string variables for storing text. We're going to do the same here. So start this project by including the string library. Now I'll instantiate a string variable to hold our user input. Call it something meaningful, user input for this instance, and default its value to an empty string. After that, I'll display a message to the console requesting the user to enter text. Please enter some text. Add a couple of new line escape characters and finish off with a semicolon. To capture user input, we use a cin feature of the IO stream. So, standard, cin, then we're going to use the pipe2 tool or read from operator, which is 2 forward arrows to pipe the value into our user input variable. This line of code stops the console pointer and allows the user to enter characters from the keyboard. When they hit enter key, the text entered is piped into our user input variable. The next part is to display this value to screen, so simply use cout to display the message. Let's build and run that. Our message is displayed to screen and we can now type in some text. I'll just type in Norway. You entered Norway. Great, exactly what I expected to see. Let's see what happens if we type in multiple words separated by spaces. Let's try entering pro dev. It only displayed the first part. The reason for this is the standard cin splits text apart by white spaces. So for every word separated by white space, we would have to capture that part into separate variables. In this instance, I typed in pro space dev and lost the dev part because cin separated that into another part. Cin does not allow us to grab the whole line. To capture both words, we need to instantiate another variable. So let's add another input as a variable. Standard string another input equals empty string. Add this variable to the cin statement. When executed, this is going to write the first part to user input, then the second part to another input. I will also add the new variable to the display line. Let's build and run that. Now enter pro dev. There we go, you entered pro and dev. So we can capture single and multiple variables in one cin line. However, what if we wanted to capture an entire line of text that's not separated into parts? We would have to use another mechanism for that. First, comment out the cin line. We're going to use a different function for this. Enter standard getLine. This is a function that takes 2 arguments. The first being the standard cin function, separated by a comma, the variable we want to use the text to be piped into. Okay, let's run and build that. I'll enter prodev again, you enter prodev and blank. So we can see that the user input variable has been given the text from the entire line and that another input variable has been left blank as it was not used. So to recap, that's two methods for capturing user input from the console. We can use the standard cin to get single and multiple separated values, or we can also use the standard getLine method to capture an entire line of text. The next part we're going to look at is the if statement and comparison operators. To start, I'm going to remove all the previous code and start with a clean main function. The comparison operators we can use to evaluate or compare the values of separate objects are the equal operator, not equal to, less than, greater than, less than or equal to, and greater than or equal to. So 6 in total. Looking at the if statement first. The if statement starts with the reserved word if. A point to note is that we can't use reserved statements in variable names as they have special meaning to the compiler. In this instance, starting a line with if tells the compiler this is a logical statement. So writing out an if statement, we have the if keyword, then the opening and closing round brackets. Like other conditional statements and loops, the if statement can be used for a single line, or we can wrap a whole set of instructions within a code block. If there is no code block directly after the if statement, then the line after the if statement is the only command encapsulated in the if condition. So for now, I'll just put a false in the if statement brackets and a single output statement to show this. Just to show that it doesn't include any more than one line, I'll add another output statement in the following line but indent it over so it looks identical. Let's build and run this. So only the second statement printed to console. What happens when the if condition evaluates a true? Okay, so now both lines are printed. However, I personally don't like to use this type of code formatting. I only show this to demonstrate that it does indeed work this way. Even for single lines of code, I would prefer to include the curly brackets like this. With even just a cursory glance, it's obvious which lines are included in the if statement and which ones are not part of it. So going forward, whenever I write an if statement, I will be using the code block convention with the curly brackets, regardless if it's a multi or single line block. I just find this convention much easier to read. So far, we have used the boolean keywords true or false in the if condition, which is not really useful. So going back to our comparison operators, let's look at some examples. Say we are writing a living or life condition for a game and we want to check if the user has 0 life left. The if statement conditional brackets I want to evaluate is if userLife equals to 0. So in the condition brackets, I will write userLife equals 0. I'll also change the message to you have no life left. A pro tip here is that if you make a keying mistake and enter only one equal symbol and have something like this is perfectly legal. It won't throw any compiler errors and it won't throw any runtime errors either. It's a particular nasty typing error that can take time to track down. In this, you are assigning a value of 0 to the userLife variable, which is then used as a value condition. And in C++, 0 is the same as false and a positive value is true. So this condition will always be false and the contained code will never be hit. You will only know this is an error when you experience weird issues where things should happen but they don't. You will likely be chasing your tail for a long while trying to track this one down. A way to avoid this is to use a constant value first, then the variable value. So instead of userLife equals 0, I use a convention where the const value, in this case the 0, is first and the variable is after the comparison operator. So 0 equals userLife. This achieves the same logical evaluation. Although, in this version, if we miss an equal symbol and put only one in by accident, the compiler will throw an error and complain. This is because it's not possible to assign a value to a constant literal, as 0 can only be 0, 1 can only be 1, and so on. These are constant values. A variable value can change, but a number can only be itself. So if we enter a constant number in our code and try to assign a value to it, the compiler will complain. It means we can trap assignment errors here, like this, as we code rather than later at runtime. Next, say we want to do something whenever the user does not have max health, less than 100, like reduce the difficulty level. We can write 100 not equal to userLife. This is the not equals operator and will evaluate to false if userLife is 100. Otherwise, it will evaluate to true. Next, say we are writing a system to allocate tickets to events, with some events requiring customer to be over a specific age, say 18. The system already has their date of birth on record and can automatically calculate the age for us. So we simply use the value provided, in this instance as customerAge. So in the if conditional brackets, I will write 18 is less than customerAge. This will evaluate to true if 18 is less than the customerAge. If customerAge is lower or equal to 18, then it will evaluate to false. Although this is not quite right. We want 18-year-olds to be able to get tickets, so this won't work. We would have to change the age limit to 17, which is not right either, or use some other operator. In this case, we can use the less than or equal to operator, which looks like this. 18 less than or equal to customerAge. This time, it also includes the 18 in the true condition, so now it will evaluate to true if 18 is equal to or less than the customerAge, and false if 18 is greater than the customerAge. Again, this may seem a bit backwards putting the const first, but it's the same logic in verse and helps to pick out typing errors. Greater than and greater than or equal to work in a similar manner, but in the other direction. Back to our game scenario, we want to provide powers and other benefits if a gamer has 20% or less health. We could write 20 greater than userLife. This will evaluate to true if the user life is 19 or less, and false if 20 or more. But again, we are missing out the 20%, so we can include the equals part. So 20 greater than or equal to user life. Nice. The operator we use depends entirely on the problem we are trying to solve. So back to the main example. What if we want to do something if the main if isn't true? We can use the else keyword to catch any other conditions. For example, if we want to check if your user is 18 or over, then allow the sale of a ticket. If not, then display a message saying the user is not of suitable age. So the first part is the if statement, as we have already covered. Then we add the else. Here, I'm simply going to add a console message stating the user is not of suitable age. Else, like if, can be used with or without curly brackets. Again though, I use brackets because it makes it easier to read. So if we build and run this, we can see what happens with different values. Starting with 18, we hit the ticket sale code. Great. Changing this value to 17, we get the unsuitable age message. Try 9 now, and again unsuitable age message. Now 125. Cool, ticket sale code. What if we want to add another condition, say a concession for older customers, 55 or over? We can use an else if statement. This goes between the if and the else statement at the end. So else if 50 less than or equal to user age. Now pop in a message for the concession code, build and run this. Make sure age is still set at 125. Why did it only run the ticket sale code and not the concession sale code? Well, this is because it will only ever select one condition, but it will start with evaluating the top condition, then the next, and so on until it gets to the final else. In this block, the else if will never hit, as the first if will always evaluate to true first. So if we want to check for a concession sale, we need to make that the first condition we check for. So move these around, moving the top condition down and the middle condition up. See now that we are checking for the concession first, then over 18. Note that on if statement structure, the first statement must be an if. We can then have 0 or more else if statements, then we can finish it off with an else statement. An if statement must start with an if condition. It can be followed with else if statements, which are optional, and can catch all other conditions with an else statement at the end, which again is also optional. Now build and run this and see what we get. Cool, we got the concession sale code. Now try with a value less than the concession age, 25. Great, we get the ticket sale code. Now for a value less than the required minimum, 9. Excellent, we get the else condition, unsuitable age. Okay, moving on to comparing characters and strings. When comparing characters, we can simply compare character to character, like this. This will evaluate to true. If I change the constant in the if condition brackets like this, and run it, it will now evaluate to false. There are a couple of things to note here. First, the const value. The B character is first. Also, the character value is encapsulated in single quotes. Remember, when working with characters, make sure to use single quotes and compare the same types, character to character and strings to strings, etc. Try not to mix types. That covers characters for now. When comparing strings, we can use the equals or the not equals operators. String objects also has a function called compare that we can use and looks like this. There is no difference in the result of this statement compared to using the equals operators. However, the compare function evaluates to lower, equal to and greater than, providing a number we can use to compare. A value of -1 is returned by the compare method if the variable value is less than what you're comparing it to. 0 is returned if equal and 1 is returned if greater. I will cover where this is useful when we start looking at sorting algorithms. For now, feel free to use either the compare or the equals operator, as these statements both do the same thing. That covers console input, the if statement, and comparator operators. Now, let's look at a scenario we have been assigned that wrap up console input, user input, and if conditions. Again, assignments for this lesson can be found at the GitHub page. You can find the link below. For these specific assignments, check out the part 4 folder. This time, I won't show the briefs on screen as they contain feature and change requests, which make them run a few pages long. So head over to the GitHub site and check them out there. To make the assignments closer to real-world examples, we will be given revisions and feature requests, and we will be expected to amend or extend our code to meet these new requirements. This is typical of professional software because there are always changes. The project brief I'm going to look at for our example is the brief for Flanag's Audit. Feel free to follow along as I work through this project. Flanag's Audit is a financial company that perform audit checks for other companies. Due to the repeat nature of allocating transactions to transaction codes, they want a tool that will display a group code for a specific transaction as a lookup aid. Let's start by creating our project. I'm going to call it F-Audit Tran Coder, and to save it to our projects area in the Part 4 folder. Now I'm going to enter code comments for the sections I need to implement. So initial display message, grab user input, evaluate user input with an if statement. Now on to the implementation. Let's start by displaying our message. As we're going to be using strings, let's include the string library now. Let's create our input variable, input var. As the input we're going to evaluate is two words separated by a space, we need to use the standard getLine function so it doesn't split our input into multiple parts. Now we have an input, it's time to evaluate it. For the if statement, I prefer to use functions, that's just my preference. You can use the double equals method if you wish, but for now I'm going to use the compare method and give the term hotel stay as the argument. With this method, we use the equals equals 0 as our check and add opening and closing curly brackets for our if statement code block. In here we will display the department code 11962. And the else block, we will display input not recognised. Okay, let's run this and see if we can test with a valid input and an invalid input. Trying it with a valid input first, hotel stay, great, we have our department code. Now with some random invalid input, great, not recognised, that's what we're looking for. I know I haven't covered code versioning or source control, but at this stage, as I have covered the main features of the brief, I would save all changes and push these changes to whichever code repository I was working with. Actually, I would commit changes in smaller increments, but source control is outside the scope of this course. If you would like to learn more about source control and you enjoyed these lessons, then please consider subscribing as there are more pro dev courses planned. This includes a pro dev course on source control and using Git as a main version tool, which is a fairly universal standard by now. Okay, now on to the change requests. Change request 1 asks we add another phrase to be recognised. So in this instance, we can just add an else if statement. So else if, add our new condition, and display the department code. Let's run and test this. So IT hardware and enter. Cool. you get the 23195 department code. Now on to change request number 2. So this is the same as the previous request, just add another phrase. So again, we're just adding another else if. So input var, compare. Entertainment. Put another code block in for the else if. Now we display the department code 15168. Run and test this. We enter entertainment. Cool, the department 15168 is displayed. Change request number 3. Same as the previous 2 change requests, we just add another phrase. So again, we'd add another else if statement. So string compare. Office supplies. Code block for the else if. Now we display the department code 15569. We run and test. We type in office supplies. And cool, we get the department code 15569. Change request number 4. Okay, this one is a bit different than the previous requests and requires an else if statement which includes an if statement. So let's start and add the else if statement for the first condition. Input var property. Code block for this else if. Now, before we go any further, let's break this part down by adding some code comments for the stages we need to implement. So we've got declare the secondary input, display the message for the secondary input, we then need to grab the user input, and then we need to evaluate the user input with an if statement. So again, we need to define a variable for the second input. I'll call this input of sup for input office supplies. Okay, now display the message to request the user enter the subcategory. Please enter property subcategory. Use getLine to grab the user input. Now our second if statement to evaluate the subcategory. No else statement, it's not asked for, so we won't implement one. Now to evaluate the input. I'm just going to use the .compare function on our secondary input, which is input of sup. There's no point in adding too much code right now, it's easier to test with less code. So to test, I'm just going to enter the first term, and if that works correctly, I'll go through and add the rest. So let's add our evaluation term, industrial. I'm going to add the display output, prod and 0019. Let's build and run this. I'll enter the first term, property. Good, the subcategory display is shown and asking for input, so I'll enter industrial. Good, now that I displayed the correct result for the industrial subcategory, I'll go ahead and add the rest of the subcategories, else if statements for commercial, residential, agricultural and development. Now I'll add the relevant outputs for each. Okay, let's build and run. So again, we need to enter the term property first. Then we're going to try the industrial term again, just to make sure we didn't break anything. And cool, it displayed the right result. Now run again, and we'll test for the commercial term. Cool, that works too. Now for the residential term. Great, that works. Now for agricultural. Again, great, that works. And lastly, for development. Okay, great, that works too. So far, as a brief is concerned, we've completed all that is asked. However, ask yourself, is there any way to improve on this? Are there any conditions that are not accounted for? Could the display be improved? There is certainly at least one part I would query with the product owner, and that is the embedded if statement. The if which looks at the subcategory. If the subcategory is unrecognised, there is no output and no notification to the user that there is anything wrong. Adding in an else statement here would certainly fix the problem, so feel free to try and fix this yourself. You have already done this with the main if statement, so this should be easy enough for you. Similar to previous lessons, there are 3 other briefs for you to attempt. We have the 2020 Vision Games, Nautilus Diving, and Tails and Nails. I have completed an implementation for you to review and uploaded them to GitHub, so if you get stuck you can look at these to help you through. Again, I thoroughly recommend you try them for yourself first. It does help to reinforce the concepts you have just covered. I sincerely hope you enjoyed this lesson. In the next video, we are going to start looking at refactoring code with functions. This is where we start encapsulating our code into reusable blocks instead of having to write everything out every single time. See you there, and happy coding.